Hello, welcome and thank you for joining the Middle School Matters webinar entitled Math Instruction and Intervention, a live discussion session. My name is David Barrett and I'm the Assistant Director for the Middle School Matters Institute, and I'll be moderating today's call. Our presentation today focuses on the math and math interventions content dimension, the Middle School Matters research platform. The webinar will focus on several principles and practices within the math and mathematic intervention section of the Middle School Matters Field Guide. If you wish to learn more, the Middle School Matters Field Guide is available for download from our website. Our presenter this afternoon is Dr. Sarah Powell. Dr. Sarah Powell is an assistant professor in the University of Texas at Austin Department of Special Education. After teaching kindergarten, Powell worked at Vanderbilt University as a project coordinator of grants related to word problem solving and computation for elementary students. Her research interests include developing and testing interventions for students with mathematic difficulties. She is especially interested in peer tutoring, word problem solving, and the role of symbols for understanding mathematics. During 2 years as an assistant professor at the University of Virginia, Dr. Powell designed and implemented randomized control trials related to non-symbolic understanding of mathematics, manipulative use, and explicit mathematics vocabulary instruction for students with mathematic difficulties. Dr. Powell has worked closely with our institute and our schools this year with much success, so we're excited to have her here today, and I will now hand things over to you, Dr. Powell.
All right. Hey, thank you so much, David. Good afternoon, everyone. I am Sarah, and I'm going to talk to you, as David said, about mathematics instruction and intervention, especially for those students who are having math difficulty, who are struggling with math. These students may be diagnosed with a disability, or they may just be lower performing in mathematics. And hopefully some of the things that we talk about this afternoon will be helpful to those students. So we'll go ahead and get started here. That's me. Wow. Okay. Cute. All right. All right. So today's webinar, we are going to focus on instruction for students with difficulty. And that difficulty, because we're talking about mathematics, is in mathematics. And Megan said that there were some areas that you were really interested in knowing a little bit more about, and those were problem solving, fraction computation, and then thinking about slope and changing dimensions. And I'm going to spend a lot of time talking about problem solving, some time talking about fraction computation, and a little bit of time talking about slope, because I'm going to first talk about ways to enhance the mathematics instruction for students from a general perspective. So not just from a problem solving perspective, but from overall. And then we'll finish today by talking about ideas for the upcoming assessments that students are going to be taking in your state, and probably in the state of Texas or in some of the other states, and some of the ideas that we have on how to prepare students to be prepared for high stakes assessments. As we go today, if you do have questions, I would like this to be more of a discussion than me just sitting here and talking. So do raise your hand, or if you want to type a question, I can be reading those. I'm reading those as they're coming in, so I can try to answer them in real time as much as possible. All right. So thinking about instruction with students with math difficulty here. There are a lot of suggestions on ways to increase the mathematics performance of students to really individualize the work. And most of the time this is done by increasing the time that students spend in tier 2 or specialized intervention, increasing the duration, instead of only doing a 4-week program with students, doing a program for 8 weeks or 12 weeks. Or increasing the frequency, instead of being pulled out for extra intervention just once a week, being pulled out for extra intervention 3 or 4 times a week. And what we know from the research is that duration is super important. Students typically need about 8 to 12 weeks to start to demonstrate any significant change. And frequency needs to happen at least 2 or 3 times a week. If it's just a 1 time a week thing, then students don't tend to retain that knowledge as much when you come back and work with the students the next time. So those are many times like scheduling things, and you really should be focusing on increasing those ideas first. And then there's some other ideas that are not math related, like reducing the group size. Instead of tutoring in a group of 6, tutoring students in a group of 3, having students tutored in a different setting. So perhaps it's really distracting if they're they're getting intervention in the hallway. So thinking about removing those distractions and tutoring the students elsewhere. So those are more like big picture things that you do need to be thinking about even before we start to head into thinking about the mathematics. But today I am going to talk to you about the mathematics. So there are two trends that have emerged from research for students that have math difficulty and or math disability over the last 30 years. And these two trends are using explicit instruction. I should use this hand so it maps the PowerPoint. Using explicit instruction. You might also see this called direct instruction, and I'll talk a little bit about that in just a minute. And also using the concrete, representational, and abstract framework as a way for students to practice mathematics concepts in meaningful ways. So it's hands-on mathematics, mathematics with pictorial representations. And what we know from the high stakes assessment items is that students are expected all the time to represent mathematics in a pictorial way. So they have to be familiar with that. And also representing mathematics in the abstract, just with numerals and symbols. So I'm going to talk a little bit about these two trends that have emerged from the research because they are currently in 2015 the go-to method for providing quality instruction for students in terms of mathematics. Now, if you're interested, I can spend a lot of time talking about this, but I'm probably not going to do a lot of it today. But I do want to say that the research on explicit instruction reaches all grade bandwidth. So students in preschool have been shown to improve their mathematics content with explicit instruction, students in elementary grades, middle school, high school, and all the way into college. So we know that this works, and we know it works for students, whether they're working on word problems, whether they're working on fractions, whether they're working on algebra. And the other thing that we know about the concrete representational abstract framework, which you will see today, the acronym CRA, is again, it also works for students across the grade levels. So we've got research from preschool where students learn to count better if they're using manipulatives and the pictorial representations that go along with that. And then we have it all the way through high school mathematics. Paul Witzel and his team have done some really nice stuff in terms of understanding fractions and algebra with students at the high school level and using manipulatives and understanding that that increases mathematics knowledge when you have those hands-on experiences for students to use there. And there's some other reviews if you're really interested, but I want to just put these up here because I'm not just saying like, I think this is a great idea, but there's a lot of research, not only coming from special education, but general education mathematics that supports the use of explicit instruction to teach mathematical ideas to students, and then the concrete representational abstract framework as a way for students to practice these mathematics ideas. Now, one of the questions you may have is, Sarah, what is explicit instruction? Now, I know some of you have already talked with me about this because I've been to your schools and done some work with you and your teachers. So you can just, politely tune out for the next 3 or 4 minutes. But I am going to talk about the elements of explicit instruction that you should be doing in every lesson, every time you're working with a student with math difficulty. And I did not come up, I've done a lot of work with explicit instruction, but I cheat by using this book, which is awesome, by Anita Archer and Charlie Hughes. And it's a super cheap book, and it's under $30, I believe, on Amazon. And it breaks down explicit instruction, not only in mathematics, but also in all the other areas, so reading and the content areas. And so many of the ideas that I'm sharing with you, I thought they did such a nice job putting them together that I would share them in the way that they put them together. But they propose that there are 16 elements of explicit instruction. And again, these should be things that you are thinking about in every lesson that you're designing for students and in every lesson that you are delivering for students. And the one thing I will say is that when we do a lot of observations at the elementary school level and the middle school level of intervention work, so tier 2 work for students who are struggling with math, we don't always see these elements included in those lessons. So you really need to look at this graphic organizer, think about what you're doing and what you're not doing, and then focus on what you're not doing and put that into the lesson for the students. So I'll go over these in a little bit more detail on the next 3 slides, and then I'll come back to them and we can talk about them and answer any questions. So there are 3 elements of explicit instruction that you really need to think about before you design any lesson for students. So the first element is that you always need to be focusing instruction on the most critical content for the student or students that you're working with. So this critical content might be a specific skill that students need. So perhaps that skill is learning, knowing how to multiply fractions, or it's a strategy. A strategy might be how to work through a word problem and how to find the important information and manipulate that information to arrive at the answer. Critical content might be vocabulary. I'm going to talk about that a little bit later today, but mathematics vocabulary is so important. You cannot answer pretty much any mathematics high stakes assessment item if you do not understand the vocabulary. So making sure that students understand the vocabulary, have a definition that it's attached to it, and understand how to apply that vocabulary. So maybe you are going to design a lesson that's focused on math vocabulary. Or maybe your lessons will be focused on a rule. Perhaps that's like adding and subtracting integers, have rules attached with it, or different concepts. But it needs to be something that the student absolutely needs to know and does not know already. And that's where you have to use assessment data to figure out where the student is, where you need them to be, and what are those gaps that I need to fill in along the way. So the first thing you always need to be doing is focusing on the most critical content. And I know I've talked with some of the schools that I've been to before about how to decide what the critical content is. Whether we like it or not, the high stakes assessments are always a pretty good guiding document. The standards in the state of Texas or the Common Core state standards are also a very good guiding document. And your mathematics curriculum at your school is also a very good guiding document. But when we look at some of these mathematics curriculum, a textbook might have 800 pages. Well, there's no possible way that you're going to get through all 800 pages in a school year. So what are the 400 most important pages, especially for this student and those types of things? Now, the second element that we need to always be thinking about is sequencing skills logically. And in mathematics, this is extremely important because everything in mathematics builds upon prior skills. So if you are starting to work on multiplication, students have to understand addition and subtraction. And there are many other examples I'm sure you can think of. So always making sure that students do have the skills, the foundational skills, to be able to complete these more complex skills later on. And then when we're thinking about these complex skills, break them down into smaller instructional units. And sometimes you may have a skill and it may take you 3 days to introduce that skill to students, and that's fine. But for example, when we're teaching problem solving, we may teach the problem solving mnemonic on the first day, and we may not even look at word problems or any type of problem solving scenario, but we're just teaching that mnemonic. And then on the second day, maybe we're going to review the mnemonic and then work on reading the question and finding what the question is asking us to answer. And that's all you're going to do. We're not going to answer the word problem, or we're just going to focus on those small skills. And many times when we do observe teachers, they're sometimes trying to do too much at one time. So really breaking those skills into what the student can handle today, what I can review today, and then adding on to that tomorrow. And then these next elements of explicit instruction, these are the things that you should be doing while you are teaching every math lesson to students. So first of all, designing an organized lesson. So that means that your warm-up for the lesson matches the content that you're going to do, and the review at the end of your lesson matches the content that you've been teaching. So making sure that there's like a steady stream of information that's all organized around one concept or one skill for students. Whenever you start teaching, you're always going to say, here's what we're doing today, and here's why this is important, so that students can start to pick that information from their brain and say, today we are dividing fractions. So they're starting to think, okay, I know some about division, I know some stuff about fractions, and they're starting to organize that information in their brain even before the lesson has begun. But it's often that I can see teachers start a lesson and there's no like, here's what this lesson is about. And it's hard for me as an adult to figure out what the lesson is about. So imagine how confusing that is for students. So here's what we're doing today, and here's why this is important. That's basically 2 or 3 sentences. And then you are going to review any prior skills, those foundational skills that are necessary for the mathematics content of the day. This is not reteaching. If you are reviewing for more than 3 or 5 minutes, that is actually, you need to then reteach, and that's a separate lesson. But this should just be a brief in and out. It's quick and dirty. Here's how this relates to previous skills. Let's maybe practice a few of those previous skills, but now let's get to the content at hand. And I will say that in doing observations over the past several school years of students or teachers at the elementary level and the middle school level, this is one of the things that teachers spend a lot of time on. So their review might be 15 or 20 minutes. And if your review is 15 or 20 minutes, then that's actually your teaching for the day. And you should be teaching that review. So this review is in and out because you need to get on to the critical content of the lesson. Now, items 7 through 11 here are how we are delivering content to students, and I will talk about this a little bit in a little bit more detail in just a minute, but step-by-step demonstration. That means that you are showing students how to solve a problem, they're solving problems with you, they're solving problems on their own. There is a trend in some mathematics classrooms in the United States that students have more of a discovery-based or inquiry-based experience, and then you come back as a group and you wrap it all up. There is no no research that supports that for students with math difficulties at this time. Now, in 2020, that might be different, but in 2015, we know that that confuses students. So they need a demonstration by you, the teacher. Hey, here's how to do this problem. Now let's work a few problems together. Here's how to do this, and asking lots of questions for understanding, and then making sure that the students can do that problem on their own. While you're teaching, always be focusing on the vocabulary, using clear and concise language, providing students with examples and non-examples. This is when we start working with division of fractions, having every few problems be a multiplication of fractions problem. So since students have to go back and access that knowledge and apply it, and they don't just think, oh, every time I don't know the reason why, I just invert and multiply and that type of thing. And then, as I talked about before, providing guided practice and supported practice for students, and also requiring students to respond frequently. I know I've talked about this with some of you, but typically students need to be responding in some way every 30 to 60 seconds. That keeps students on task and involved in the lesson. And that response can be a yes or no question. It can be a very low level question like what's 3 plus 7, or it can be a much higher level question. How do we work through a word problem? Why does this work? Why did we have to regroup? What does that mean? And that type of thing. But the more that students are involved and responding in the lesson, the more they're going to be on task. And as you all can guess, when students get off task, it takes you a long time to pull them back into the lesson. So if we just don't allow them to do that in the first place, then we have fewer problems later on. And then these elements of explicit instruction are kind of like while the lesson is going on, and then the afterthoughts, but always monitoring student performance, both informally by asking questions, getting students to do thumbs up, thumbs down, write stuff on their whiteboard, share it with the class, and also formal monitoring of performance. So that can be progress monitoring measures, unit assessments, exit slips, that type of thing. You, the teacher, should always be providing immediate feedback for students when they make mistakes in mathematics. Don't just let another person in the class help them out, but that correction needs to occur with the student at that time. And also providing affirmative feedback. Many times our students with math difficulty are always like, oh, that's incorrect, that's incorrect. But tell students what they are doing correctly and be very specific about that. So I really liked how you regrouped that, or that was a really good use of your word problem mnemonic and that type of thing. Delivering the lesson at a brisk pace. I'm talking briskly right now because we are on a time crunch, but some of the research shows that when you speak a little bit faster, students actually have to pay attention more. So again, they keep on task instead of getting off task. And then 15 and 16, just keep students, help them organize their knowledge. So how does this relate to what I've learned before, and how is this going to relate to what we're going to learn next? Many students and adults can figure that out on their own, and so you don't need to tell them. But students with math difficulty really compartmentalize things that you've learned. So they don't really understand how the y-axis and x-axis relate to slope-intercept form unless you make those connections explicit for the students. And then providing all types of different practice for students as well. So here are the elements again, if you want to check them out. Are there any questions or anything, or things you would like to talk about in terms of elements of explicit instruction? I'll give people a minute to type these amazing questions here. All right. Well, if you have questions, go ahead and keep typing them and I'll answer them as we move on here. So again, these elements of explicit instruction, I know for those of you that have seen me, you're like, yeah, Sarah, you've gone over these before. Really be reflecting upon whether you, if you're the teacher or the teachers in your school, are they doing these things in every math lesson for students who are struggling? And in fact, you should be able to go into a math lesson either in a classroom or in a resource setting or whatever, and you should see all of these things going on, especially reviewing prior skills, step-by-step demonstrations, clear and concise language. And I can guarantee that not everyone is doing this all the time, and it's what we need to be doing. So really keep those things in mind. Okay. I'm not going to spend much time on this, but this is just another graphic organizer thinking about how to design your lesson. So you're opening, here's what we're learning today, here's why it's important, and here's what we need to review. Then your body, which is the majority of your lesson, is giving demonstrations with the students, having the students demonstrate concepts with you, and students practicing those on their own. And then the closing, which typically should be pretty brief, is here's what we learned today, here's why it's important, and here's some practice if you need to do that. And I don't want to spend time on this, so I am just going to click through these next few slides. So if you want them, they're there for you to check out at any time. But I will pause for a moment here on the body of the lesson. And this is where we talk about the modeling, which is the I do, the we do, and the you do. And again, research, you can send you 50 articles that support this method for providing mathematics instruction to students across the elementary, middle school, and high school grades. There are some different ways that, different programs will say, why don't you do a you do first, and then we'll have a we do. And that is a really nice idea, but the research doesn't support that currently for students with math intervention. So do think about that. If you've got students that are struggling with math, they're 1, 2, 3, 6 grade levels behind, this is your go-to method for designing instruction for the students. And I really can't emphasize that enough. And then here's a few other examples, and I'm going to click through these. All right. So the other trend that we see from the research, and this trend is used in conjunction with explicit instruction. This is really not like a separate thing. There's a lot of carryover here, is the CRA framework, which is the Concrete Representational Abstract Framework. And the CRA framework is having students practice math concepts and procedures in multiple ways. So the concrete is using three-dimensional objects. I have a few here. I'm probably going to get them out of the bags. We'll see. But this is a geoboard. Students can touch and use the rubber bands for this. This would be something that students could use in terms of fraction skill, in terms of geometry skill, and also in terms of changing dimensions. This geoboard is very functional for lots of different things. But it's hands-on. Students are touching the rubber bands and moving them around. Representational are pictures of the hands-on materials. So we could have just like graph paper, and students could use that for their geoboard. There are also a lot of really cool virtual manipulatives that are representational. So there's an iPad, mini iPad apps that have the geoboard on them, and students can touch the app and move it around, and it's a pictorial representation of what the students have just worked on with their hands. And the abstract level is no objects or drawings, so solving those problems with numerals and symbols. And from what we know, the research shows that students with math difficulty benefit from the CRA framework because it's giving them those connections, and that hands-on piece and that pictorial piece are so important for students to see. It helps not only with conceptual understanding, but many times the procedures that are needed in terms of solving mathematics problems. And it's also a graduated framework for learning. So many times students will start with the hands-on and move with the pictorial representations, or start with pictorial representations and move to the abstract. There's a lot of different options there for teachers to use with students, but it gives them a way to access math, and not just one way, typically not just two ways, but actually three ways. And as I mentioned a little earlier, if we look at any of this release items that are associated with the Common Core, and any release items that are used here in the state of Texas, that representational is highlighted on so many math assessment problems. So students should have a lot of practice with the representational, and then that concrete helps connect to the representational as well. So here are some examples of manipulatives. I know you all have a lot of these, so we won't spend a lot of time on them. And I do just want to say, don't call manipulatives toys, do call them tools. And anytime you bring in a new manipulative, just like I do with you teachers when I come in work with all of you, it's give you some free time to play with them. And then once there's like the 1 or 2 minutes of free play, now it's time to work with them. And that really alleviates a lot of behavior difficulties that we sometimes see with manipulatives. And then the other things that are really important is that manipulatives do not teach mathematics. Mathematics instruction is enhanced by manipulatives. So just because I've got this geoboard out and just because students are using it doesn't mean they are making the connections to the mathematics that you want them to be. So that's where explicit instruction comes in. You use explicit instruction, and then the CRA is a tool to enhance the explicit instruction that you're providing. And if students don't understand manipulatives, try another manipulative. And also, not all students will learn best with manipulatives. So don't say, like, you have to learn how to use the set model to divide fractions. That's not true. It's going to be somewhat helpful for students to understand how to divide fractions with the set model, but move on to what's most important, and that is dividing fractions in the abstract with numerals and symbols. And here are examples of the representational, and then the abstract is just with the numbers and symbols there. So I'll pause to see if anyone has any questions about the concrete representational abstract. That's okay. I mean, if people don't have questions, that's make my job easier. But I like answering questions. I like talking to you guys. So, okay, so one of the questions is about inexpensive manipulatives, which is a really good question. So I find most of my manipulatives on a website called Hand to Mind, and that's HAND numeral 2 and then MIND. And their stuff is kind of expensive. So I will find what the manipulative is called, and then I will look for it on Amazon because many times you can see that teachers sell a lot of stuff that they have in their classroom and that they're not using anymore. And also there are a lot of knockoff manipulatives, which are super helpful. But so like these geoboards, there are different types of geoboards, but these were actually cheap. I think I got a class set of like 12 of these for $30 or $40, which I think is a pretty good deal. But you can also use like paper clips instead of buying clips. You can, I'm trying to think of other things I have. With all the fraction manipulatives, there are always paper copies of those, which you can either print out or use with an Ellison machine to make sets for every student instead of buying the expensive fraction circles and things like that. But I do suggest always having a manipulative library. So if you are an 8th grade teacher and you want to buy an awesome manipulative called AlgeBlocks, those are very expensive. So why don't you and all the 8th grade teachers put in to buy a class set? And typically you're not going to be using the manipulative every day. So you can share the manipulative and house them in your teacher workroom and then just go pull and use them from when you need them. And the other thing about manipulatives is not every student in the class needs a set of manipulatives. Typically students can be paired or in a trio or in some type of group setting. And for like example, I have these angle legs, which I know some of you guys have bought, the angle legs manipulatives, which I really like. But a group doesn't need that many of these to actually be able to make the shapes that the trapezoid and the rhombus that you're expecting them to make that day or whatever the lesson is. So you can take what they consider a class set and split it into many, many pieces. So, but I think manipulatives are getting cheaper than they used to be because more than one company is making fraction circles or making the angle legs. And so then they kind of keep the market a little bit competitive. So, and also inexpensive manipulatives are really easy, like for counting and things like that, but they're a little bit harder for algebra tiles, but even those are pretty inexpensive as well. So, all right, so let's talk a little bit about problem solving. So this was one of the content areas that Megan said you all were interested in, and it is absolutely necessary that students know how to solve problems, but mostly solve word problems, because their high stakes assessments are going to be littered with these. So let's go ahead and talk about that. So here is a word problem. This comes from an assessment used within the state of Texas. And I just want you to look at this problem, read through it, which you should always do when you do a word problem, and that's not always what students do. But look at like what the students are being asked to do. So just take about 30 seconds to read through this problem, and then we'll talk a little bit about it. All right, so in this problem, if we were in a room, I would have you discuss this with your neighbor. But there are a lot of things that students are expected to be able to do to solve this one problem. First, they have to have reading skill to read the word problem. And this is the most difficult thing in mathematics is that almost every mathematics item from about third grade on requires you to read to solve a word problem. And what do we know about students that have math difficulty? Over 50% of the time, they also have reading difficulty. So teaching students to, if they don't have strong reading skill, be able to read in a smart way. So the first thing is that we need to have students paying attention to the words that are most important. Here, the number 4 out of every 16 is very important. Red light is not as important. So, but students may be really, really focused on that. So we have to teach students how to read these questions and read them smartly. Other things that students have problems with is figuring out what they need to do in order to solve this problem. This problem ends up breaking down. This is a ratios problem, and a student can set this up with a pretty simple ratios equation, but it seems more complex than that. So students have to be able to read the problem, interpret what the question is asking. It's about how many intersections did she have to stop for a red light, and then what do I need to do to solve that intersection? Here I'm going to set it up in a ratios equation, and then I'm going to end up cross multiply and find the answer. So students have to have the multiplication knowledge, they have to have the ratios knowledge. They have to be able to pick the relevant information. Which numbers do I need? Which numbers do I not need? And then they need to be able to figure out which of these answers is reasonable and which is not reasonable. So just from this is a fairly simple word problem. It doesn't have any irrelevant information. It's not asking students to write an equation to represent the word problem. There's a lot of things that students need to get at. So for every word problem, if you do one thing in terms of word problem solving and just problem solving in general, is you need to teach your students an attack strategy. And I like the word attack. It is a little bit violent. So if you want to come up with a word that's a little bit less violent in terms of word problem solving, you're welcome to do that as well. But this strategy should work for any problem type. And I have some ideas for you on the next few slides. Some of these are a little bit more elementary based. Some of them are more middle and high school based. So you should choose an attack strategy that is going to be applicable for all the problems that the student is going to see. And almost all of these attack strategies use a mnemonic. For example, STAR, the mnemonic is STAR. So search the problem, translate it into an equation or a diagram, answer it, and review the solution. So if you used STAR, students should know that every time they see a problem, they use STAR. And you could ask them, what do you do every time you see a word problem? Oh, I use STAR. And they should be able to tell you what STAR means and be able to STAR through every type of word problem. Students can ride through a word problem. Less cute is the SQRQCQ, but still works really well. And then here are some others. The solve strategy, a lot of schools use that. Draw's pretty good, but I don't like that the students don't read the problem first. So I have a little bit of a problem with that, but that's okay. And then signs is good. And then the one in the orange comes from a middle school program from Marjorie Montague's team called Solve It. And that's how they have students attack word problems. But it doesn't matter what the word problem is. It might be using division of fractions. It might be subtraction computation. It might be ratios. It might be solving a simple algebraic equation. Students should have one attack strategy that helps them work through that problem. So for example, if I was using, I'll just slip down there, that's okay. If I use STAR, then when I see this problem, I see, oh, there's a word problem. I know I need to search the word problem, which means I'm going to read it. Then I'm going to translate and figure out what's going on there. Then I'm going to answer and then check for the reasonableness of my solution. And I'm going to do that for every problem. And this seems so simple. When I talk about these attack strategies, I always feel that people should be like, yeah, duh, Sarah, that makes sense. But if you asked your students, what do you do when you solve a word problem? I can guarantee that the majority of them don't have an attack strategy. And then that's where math seems so magical. And then that's where students just start taking numbers and manipulate them and answer the problems incorrectly or not at all. So giving students an attack strategy, super important. It should be explicitly taught. and it should be emphasized every time students are solving a word problem. And again, I do not care which word problem strategy you use. You need to find one that works for your student or your situation, but just use it consistently. Now, if your school is super awesome, you guys would have like an attack strategy that was used across grades like 6, 7, 8. So the 8th grade teachers wouldn't even have to teach it. They would just know, all the 6th grade students would know, like, oh, I draw through the word problem or whatever it is. But like giving students an attack strategy is just really one of the most helpful things you can do. And it seems so simple, but people don't do it. All right. Then there are some other general strategies that students should be familiar with. I'm not going to spend a lot of time on these because these are the strategies that are typically taught in math curricula already. So there's the list. You can check it out. If we had more time, I'd go over it, but we don't. And then another thing that students need, first attack strategy, and then they need some notational strategy for working through these problems. So that might be underlining important information. Maybe I don't suggest underlining the whole question because then students just find the sentence that has the question mark and they underline it and they're not actually like getting any information from that. But it might be underlining the label. So in that question that we looked at earlier, how many intersections did she go through with a red light? And I would underline those. Maybe I'm going to circle the important numbers. 16 was an important number, 4 was an important number, 36 was an important number. I'm going to circle those. If there were numbers that were not important, maybe I'm going to cross those out. Once I used numbers in an equation, checking those off. Very helpful strategy. Many times students can say like, this is an important number, and then they forget to use it. So check it off as you write it into your ratios equation, and then students will realize that, yep, I used all the important information. And the third thing here is writing equations. Equations have been used with students as young as 1st grade to represent word problems all the way through high school. And they're the one thing that students have at their fingertips. You can just write an equation at any time. So teaching students how to write an equation that represents addition problems, how to write an equation that represents multiplication problems, how to write an equation that represents ratios problems. That kind of information is going to really help students in the long run. Before I talk a little bit about problem types and things like that, I do want to say that in many classrooms, I actually haven't seen this much in the Middle School Matters classrooms, but I have seen it in other classrooms, is that you'll see posters that talk about using keywords. And both of these posters are very cute and very pretty. And if I did not know better, I would probably use them. But the thing is that we see many times is that students use these keyword posters incorrectly. So students do need to understand keywords, and that more mean, what does more mean? What does total mean? What does divided and separated mean? Like, what does that mean? But the problem is many times students see these problems in a word problem. So for example, I see the word separated, and I think automatically, oh, separated is a division word. I need to divide. When many times separated is presented in a scenario which actually makes the students multiply to get the correct answer. I'm not going to do much more of this, but I want to say emphasize that there are keywords that students need to understand, but do not show stuff like this because then students just look at the keyword, they see subtraction, and then they just take two numbers and they subtract, and that does not actually help understand what the word problem is asking. And many times that does not give students the correct answer to the word problem. So keywords, not a terribly great strategy. And some textbook series stick with it. And for students with math difficulty, they just say, they make those connections and then they don't make sense of what the words are asking them to do. So here are some keywords that students should be familiar with, but they shouldn't think that like multiplication or product only means that I multiply. So instead, students should learn about word problems by what we call schema or problem type. So you should have an attack strategy, and then students should be like, okay, in this problem, this is a ratios problem. So I'm going to use my ratios graphic organizer or my ratios equation. And then that is going to help them get the information from the word problem, fill it into the equation or graphic organizer, and then solve the problem correctly. So while it goes back to the elementary grades, students should be familiar with some of the additive schema, which are these on these slides here. Total problems are parts put together into a total. Even though this seems very simple, there are middle school problems that ask students to do this and they can't always do it correctly. So is this word problem asking you to take parts, maybe 2 parts or 3 parts, and put them together? Then that's a total problem. And then students learn how to solve a total problem. Here's a graphic organizer for total problems. This comes from Asha Jatendra and her research team up in Minnesota. But students are given this graphic organizer here, and then they fill in the parts that they know, or that if they know the total. Then they put a question mark in the box if they don't know that information, and then they can use this graphic organizer to write an equation that represents the underlying schema of the word problem, and then solve that word problem accordingly. Here are difference problems. Difference problems are two amounts compared for a difference. And again, these are typically taught in second and third grade. But what we know is that middle school students many times are asked to find a difference and then do something to that difference, perhaps multiply it or divide it or what have you. So students should be familiar with understanding a difference problem is comparing. And here's a graphic organizer that would help students organize their information. These graphic organizers that I show you today are very, very simplistic so that students can draw the graphic organizer if they need to. So if they realize this is a difference problem and I can organize my word problem information with 2 circles and a square, then they can go ahead and draw those 2 circles and a square, put in the information, and then they can solve the problem like that. And then students also should be familiar with change problems, which is an amount that increases or an amount that decreases. And again, these are taught typically at second and third grade, but we see them appear in middle school when students have to do something to a change and then they do something more to that change problem. So change join and change separate problems. And here's a graphic organizer that many students with math difficulty find helpful for organizing information from a change problem. And you can see here, this graphic organizer shows that change problems occur over time. So that's why you have the arrows there indicating there's a beginning amount, then there's a change, and then there's an end amount there. And this is an example from some work that we've done for students. And you can see here we have students, this is a total problem. They write a total equation. They're writing an equation with X to solve the word problem here, but they've underlined important information. They've checked off the numbers that they've used and so on and so forth. And so these are just very helpful strategies for students to use there. Now, here are some word problems that come from some release items in the state of Texas. And I just wanted to look at these problems to show you that they are from the later elementary grades and middle school test release items, but they actually are pretty simplistic in terms of what they're asking students to do. So the first problem about Mrs. Lanier, she saved some money, then she spent some money, and then she saved some more money. So that's actually a change problem with 2 changes. I had a change, then it decreased because I spent some of the money, and then it increases again. And so this problem confuses students because they don't really understand that they're going to manipulate the numbers twice. But if they are like, oh, that's a change problem, first the change decreases and then it increases, they can solve this problem very, very easily. The other problem about Ramon with the sheep in the 2 fields, a lot of sheep, may be hard for students to understand this one, but based on real life experiences. But anyway, he's got sheep in the 2 fields and there's sheep in 1 field. How many sheep are in the other field? This is a very simplistic part whole total problem, but students do have difficulty with it because of the larger numbers and organizing the information and understanding that one of the parts is missing and that I don't actually have to find the total. And this is an example of Ramon has a total of 815 sheep. 815 sheep. And where if I was a kid with a math difficulty and my teacher said total means add, I would take that 815 and add it to 348 and be like, I'm done, I solved the problem. When actually here you're given the total and you have to find one of the parts. And that's why students need to not use keywords, but understand that total's cueing them into something, but that total does not mean you're going to add to solve the problem. And then the other one is a graph about doing homework and so on and so forth. And then we have multiplicative problem types. And so these are your later elementary grades into middle school. They're very, very common on different types of word problems. But here we have groups and there's a number in each group and then we solve for a product. And that is a different type of problem than this comparison problem where we have a set that's multiplied by a number of times that also equals a product. But you can see for both of these, there are equations that represent these problems. So this is G times N equals P, or S times T equals P. And students, if they can set up this equation, then they pick the information from the word problem, map it onto this equation, figure out what's missing, and then they solve the problem accordingly. Now, just because they set up a comparison problem with s times t equals p, sometimes students will have to divide to get the answer. Sometimes they'll multiply. They learn that through explicit instruction, but it is a way to help them organize the information from the word problem in a meaningful way. And then there are other multiplicative problems that we don't really see that often, so combinations, and then the other is product of area, and we don't see that a ton as well. But here are some graphic organizers that students can use to just draw very quickly, plug in the word problem information, write an equation from the graphic organizer, and solve. And again, this is one of those things that many times seems very, very simple, but students do not do this. They don't have a way to attack the word problem. They don't have a way to organize word problem information. And without those two things, it's almost impossible to solve word problems. So giving students these strategies and teaching them explicitly to students, super, super, super helpful to do. So here are some other word problems that I picked. These again come from late elementary and 6th and 7th grade assessment items. The top one is an equal groups problem. The second problem about a person named Zenobia, which is an interesting name to have on a word problem assessment. That one is a combination of a total problem and an equal groups problem. Number 3 is an equal groups, 4 is a combination total and equal groups, and 5 is equal groups. So you can see that just by knowing about equal groups and total problems, students can solve all these problems. And then there are other problems that we see in middle school, for example, like ratios and proportions. Here's an example of just a graphic organizer that goes along with this. They use the FOP strategy to attack every word problem, and then they use this graphic organizer to organize the word problem work, write an equation, do the cross multiplication, and solve the problem. And then this just takes this information that seems complex to students and organizes it in a meaningful way. So here are some more examples. These all come from middle school for examples of word problems that would help with the problems we've just talked about. The first one, we could have used that previous graphic organizer about ratios. The second problem, we could have also done the same thing, third problem as well, and fourth problem. So you can see that just by understanding this one thing about ratios and proportions and how to get the information from ratios and proportions and put it into this graphic organizer that's turquoise, then students could solve all of these problems. But the thing is, this requires a lot of explicit instruction. So teaching students the attack strategy of FOPs, teaching them about this graphic organizer and how to fill in the graphic organizer, then how to take in that information from the graphic organizer, put it into equations and solve it. But it does break it down into manageable steps for the students, and it helps the students organize their work. And so then therefore students could solve all of these problems successfully, whereas before many students would just be like, I don't know, and they would just choose one of these answers and move on to the next question. And that seems a little dramatic, but we know a lot of students that do that. And here are some other examples of word problems. These are all from middle school that students are expected to solve, that you could solve very easily using any of the graphic organizers or any of the equations that we just talked about. And then finally, when we're talking about problem solving, you do have to focus on explicit instruction of vocabulary. So I want you to look at this problem. This is from middle school. This is a typical middle school problem here. And just read the word problem very quickly and count the number of novel vocabulary, mathematics vocabulary words that students have to know. So with this problem, I see circular, I see hole, diameter, millimeters, equation, R, radius. Those are all new, and then circular, hole, and millimeter up here again. So that is 7. I can't do it for you guys backwards, but that is 7 absolutely necessary vocabulary words that students have to be able to understand and interpret and manipulate in order to solve this problem correctly. And this is the thing about mathematics, is that vocabulary, you can read a lot of articles. It's like, yeah, mathematics vocabulary is important, but people do not teach it as explicitly as it should be taught. And I could not answer this question if I didn't understand circular, diameter, equation, what R represents, radius. So you have to provide that vocabulary. And so I believe that mathematics vocabulary instruction should really be like a daily occurrence in mathematics instruction. So it's, and the mathematics vocabulary should match the lesson. And then students should be reviewing it all the time. And here's another example: dimensions, solid, shape, triangular prism, best estimate, volume, cubic centimeters. I mean, those are a ton of keywords that students have to know in order to be able to solve this problem correctly. And many times I think like teachers kind of gloss over that and don't give students opportunities to read these vocabulary words and interpret them, or to develop here are some graphic organizers about vocabulary and help organize this mathematics vocabulary work. So many schools use the Frayer model. I think that's great. I wouldn't do it for every mathematics vocabulary word, but for some of the more important ones. But I do want to say, like this picture from the right-hand side, this is like a mathematics vocabulary word wall. And these are great, but then there's real no definitions that are associated with these, and it's maybe a little bit overwhelming. So I would pick a few of these and work on them until the students were familiar with them, and then introduce a few more there. But explicit instruction should be used to teach vocabulary. The I do, we do, you do model is great. I'm going to talk to you about a new word today. It's dimensions, and then you're going to provide a student-friendly definition. You're going to practice what dimension means and give examples and non-examples of it, and then have the students practice the word dimension with you. But not only should students should be able to speak the word dimension, they should also be able to read the word dimension, because they are going to be reading those when we see them on high stakes assessment items. So that's all I'm going to say about vocabulary. If you want to talk more about how to explicitly teach mathematics vocabulary, I'm happy to do that. It typically takes a little bit more than 5 minutes, usually about an hour or so to go through some ideas there. But thinking about every lesson that you're teaching in mathematics, what are the important vocabulary terms? How am I going to teach those using explicit instruction? What are the student-friendly definitions am I going to provide? And how are students going to be asked to interpret this vocabulary later on? So the interpretation of it is extremely important as well. So are there any questions about problem solving or the vocabulary component, or anything that you all have run into in terms of problem solving that you would like to discuss with me, or have me talk a little bit about? Somebody's typing. Oh, well, thank you, Christy. That's not a question about problem solving, but I had to read it to understand it. So, okay, all right. So one of the other things that Megan said that you all were interested in talking about a little bit, and I'm only going to spend like 5 minutes on this, and I usually spend 3 hours on it in class, is that fraction computation. So students just need a ton of practice in terms of computation with fractions. Actually, multiplication and division of fractions is an easier thing for students. It's addition and subtraction of fractions with unlike denominators. So using explicit instruction, using a lot of hands-on manipulatives, some of the ones that I use when teaching this concept, like the fraction tiles, fraction circles. That's an all right math manipulative, not my favorite. But as some of you know, my favorite is the set model of fractions. And if you do want to know more about that, I can meet with you at another time. But students should first work on adding and subtracting fractions with like denominators to talk about the process of addition and subtraction. Because when students add and subtract with unlike denominators, and they just add the numerator and add the denominator, yeah, Christy, I can send them to you, the graphic organizers. When they are just adding the numerators and adding denominators, that means they don't actually understand what's going on when you are adding fractions. You're adding parts to the same whole. And if students understand that, we would probably see a lot less difficulty in this area than we do. So do practice with adding with like denominators first. And again, manipulatives and pictorial representations are perfect to use here. And then add and subtract fractions with unlike denominators. One of the things that we've used with students in the past, sorry, I'm like stretching over here, are these factor strips. And these are the simplest, these are the most cheap, the cheapest manipulative that you can ever buy. But they're basically just the factors for any number just written out. So here are the factors for 6, 12, 18, 24, 32. Then maybe here are the factors for 7. But many times students have difficulty finding the common denominator. One of the things you can do is just multiply those two denominators, and that's your new denominator. Or you could do something like finding the least common multiple. And here what I do, let's say I have a fraction with a denominator of 7 and a fraction with a denominator of 6. I just move these strips along until one of the numbers matches up. And here I've moved them, and sorry to do this kind of tricky, but here I see that the least common multiple is 42. So how many times did I have to multiply 7 to get to that least common multiple? 1, 2, 3, 4, 5, 6 times. How many times did I have to multiply 6? 1, 2, 3, 4, 5, 6, 7. So then I'm going to multiply this fraction by 7 and that fraction by 6 to then end up getting to having the same denominator. And that's just like a very cheap tool that teachers aren't always aware of, that students find very, very helpful and help in terms of finding the common denominators. But another way, just multiply those denominators and you get bigger numbers, but it still is pretty helpful strategy. But the thing here is just practice with manipulatives, practice with the pictorial representations, and then practice in the abstract. If students can't do this in the abstract, then you're wasting your time with the manipulatives to help with the conceptual understanding. So just using those factor strips, doing the multiplication, and so on and so forth. This slide's not that important, so I'll skip that. But the other thing the students have to do in terms of fraction computation is be able to multiply and divide. And this is much easier. It's very procedural. When we're multiplying, we just multiply the numerators and multiply the denominators, and there's our answer. But you can also help students understand this concept. And this is important when it comes to interpreting word problems. Because once students get to like, oh, I just have to multiply these fractions, that's easy. But students have a hard time of getting the information from the word problem and figuring out how you need to manipulate it and what you're going to do with it. So there are 3 models of fractions, and this is the multiplication model here. I'm multiplying 2/3 times 3/4, and the interpretation of that is 2/3 of 3/4. So what is 2/3 of the fraction 3/4? So here you can see the red bars show 3/4, and then the green bar shows 2/3 of 3/4. So 2/3 multiplied by 3/4 is 1/2. We see that with our link model. This is the area model of fractions. So here's a circle. There's 3/4 of it is green. What's 2/3 of those 3/4 pieces? Those are the stars over those pieces, and so that's 1/2. And then here's the set model of fractions. Here I just showed a denominator of 8 because you don't always have to be working within the same denominator. And I take 2/3 of that area. So that's nice to show students what's going on because it does relate to word problem solving. And that's one of the things we are always thinking in mathematics is these are just not separate skills, but they all combine. And so many students you can ask them, how do you multiply fractions? And they could say, oh, multiply the numerator, then I multiply the denominator. But it's getting that information set up so that they can do that. That's the trickiest part. And this is just another graphic organizer of multiplying fractions. I love talking about this, so if you want more information on multiplying fractions, please let me know. And then division of fractions, there are some very cute mnemonics. I don't know the reason why, just invert and multiply or copy, change. Those work with division of fractions. But again, students should understand why this works when we copy, change, or whatever we do with fractions and division. So here's a problem, 1 1/2 divided by 1/3. And so the interpretation of this is how many 1/3 pieces or 1/3 sizes fit into 1 1/2. So here you can see on my number line, I've got 1 1/2 highlighted with my green line. And then I have those 1/3 pieces. So 1/3 pieces fits, a second, a third, a fourth, and then 1/2 of this last 1/3 piece fits into 1 1/2. So my answer is 4 1/2. And that often doesn't make sense to students because they're like, well, how did I get to 4 1/2 when I'm dividing? You've always told me that when you divide, your answer is smaller. which is one reason we shouldn't teach those whole number rules to students as like steady rules. But this also gets to this interpretation. And I see this problem many times as a word problem that um, if I have 1.5 cups of sugar and I want to make a batch of cookies and each batch requires 1/3 of a cup of brown sugar, how many batches can I make if I have 1.5 cups of sugar in my cupboard? And so it's really simple to do the division here, but it's very complex to interpret that from a word problem and then putting it into this equation. So the more that students have this conceptual idea of what does it actually mean to divide fractions, they're going to be better off there. And so here's the area model of division for fractions and the set model. And I can, again, talk to you about this in more detail if you are interested. And here's a picture of it. We won't go through that now. But I do want to show that these are some word problems from late elementary and middle school in terms of having students manipulate fractions with computation. These are a little bit more simple. This one's a little bit more complex, and as are these. But students do need to have fraction computation skill, and they need to be able to solve these from within word problems. So that the more that you can teach students the attack strategies for word problems, how to organize word problem information, and then the students need to be able to manipulate the computation in order to solve the word problem correctly there. So then the other questions that came up today were about slope, and I am not going to spend much time on this. I'm going to send you to some of my resources that I use when thinking about this. But students have to understand slope-intercept form. They should be able to tell you what y means, what m means, what x means, and what b means. And I can guarantee that many students wouldn't actually be able to interpret that for you. They need to understand the word, what is a variable? So here's our math vocabulary coming in. What does slope mean? What's my y-axis? What's my x-axis? What does coefficient mean if we're using that term and that type of thing? So students need a lot of practice with that. There are some manipulatives. Here's a manipulative here that is a x and y axis that I can actually use to graph using a slope-intercept form, so students can have some hands-on practice with that. You can also use a geoboard. It's a little bit trickier. This is kind of expensive, but it is a nice thing if you are having students use manipulatives to do that there. And here are some sites that I've used before that I think do a really nice job of explaining slope-intercept form. But the thing here is practice, practice, practice within explicit instruction and concrete representational abstract. So that is introducing. Today we're going to talk about slope-intercept form, writing that term on the board, talking about what that means. And maybe on the first day you're only going to talk about what M means because you've been working about rise over run and students understand, the slope and things like that. Or maybe you're first going to focus on what B means and plotting B onto an axis and having students just do that part and then adding in the other parts. Many times teachers throw the whole thing at students and where they should have broken this up into 4 days of instruction or 2 days of instruction or what have you. And the same thing with changing dimensions. I know I've been talking with some teachers here in Texas because this is something that they're really concerned about. Geoboards are super helpful for this. But again, it's just grid paper, that type of thing are really helpful. But hands-on practice for students. So where they're drawing the pictorial representations, where they're counting the sides and interpreting the sides and then figuring out the change from one object to another. And here are some of the sites that I've been on that I think do a really nice job of helping teachers break down this skill into manageable pieces there. And then finally, I know we're over on time, but in terms of assessment considerations, I write practice, 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 but I also wrote down quite a few other notes here. So things you need to practice, the setting. So where is the student going to sit? Coming in, getting ready, sitting at your seat and be ready to take the assessment. And what are the materials that you're going to need out, whether that's sharpened pencils and things like that. All of that should be ready. And students should be able to get into like their assessment seats within a minute's time. So actually timing that for a week up to the assessment, say, okay, now we have 1 minute to get into our assessment places or our star places or whatever you want to call them, and let's go. so that there's no downtime, and so you can really, really focus on getting to what you need to do. Typically, assessment periods are not that long, and you have a lot of stuff you have to do during that. Teaching students how to be a smart assessment taker, and this should go without saying, but not everybody always goes over this with students. So how to read all these problems. So again, having that attack strategy and being able to organize the information from those problems. And that might be students underlining the important information or circling the important information and things like that. Students should be able to paraphrase every question. So what is this question asking me? They should be able to have like almost a self-regulation strategy where I read it. Okay, now I need to figure out how many faces is on this shape or whatever it is. Giving students a strategy and giving them time to practice crossing out the wrong answers. So on most assessments, it's multiple choice, although there are some open response items. But okay, which of these is not applicable? Go ahead and crossing those out. And then also how to fill in answer choices. One of the things we also see in the state of Texas is students have to understand how equations represent word problems. So many of the answer choices that students are expected to know is an equation that would get them to the correct answer. So they don't need to know it's 27, but how do I arrive at 27? And which is always a little bit odd, but it's getting more at the underlying schema of the word problem. So students have to be able to read those equations and interpret the word problem information and put it into an equation. And then if possible, and sometimes assessments, especially those that are given online, don't allow for this, but giving students the opportunity to do the easier problems first and then go back and try the harder ones. As an adult, if you are given a very difficult problem, you kind of want to skip it and come back to it later. And so we need to teach students that that's okay to do. Maybe circle the problem that you're going to come back to later or mark it with a star, or whatever it is. But many times students, if problem number 2 is really difficult, maybe they don't understand the vocabulary, they don't know how to pick the equation that represents problem number 2, they get so hung up on number 2, then they get anxious about it, and then that's going to have implications for the rest of the assessment. So practicing with students. Here are 10 items. I want you to try the easier problems first, then go back and try the harder ones. And giving them the practice to do that and not just expecting them to do that on test day. It's a smart test taking strategy that we just don't see students with math difficulty have all the time. Oh, Christy, I can't wait to get to your question there. And then also if students have accommodations, the biggest one is calculator use. If they have a calculator use or time and a half as accommodations on their high stakes assessments, you should be using those all the time so that students are familiar enough with those accommodations that it's not a question as to how they need to solve that use that accommodation when they are working on their high stakes assessment items. So that's all I have for you today. I think I was supposed to end at 5 to allow 30 minutes for discussion, so I apologize for talking so long. So if you do have some questions now, feel free to raise your hand, or if you want to type it in, I can read that as well. So we do have one question from Christy. Do you have any advice for schools whose textbooks curriculum emphasize the exploratory portion of instruction versus explicit instruction? So many textbooks, general education textbooks, use this approach that's presenting students with a problem-based scenario. Andrea from Roosevelt, we were talking last week when I was up there with you guys about some of your algebra items. It's all, here's a problem, and then let's step back from this problem. And that idea is great if you are strong in mathematics or if you can reason well. But for students with math difficulty, who again are often 3, 4, 5 grade levels behind in mathematics, that just is really not a good idea. And there's no research that supports that strategy. There's a ton of research that supports explicit instruction. So if your textbook is using that, I think the first thing you have to say is these students are struggling. We need to focus on critical content, and we're going to teach critical content this way. It's much easier to do if students are being pulled out and serviced like in tier 2 or tier 3 intervention modules. It's much more difficult to do when the student is actually, when you have to use the textbook. But the thing is, it's like where you can always ask, what's the evidence base to support this? And here in the United States, No Child Left Behind says that, quote, scientifically validated practices should be used in every classroom at all times. An IDEA, our special education law, says that students should be instructed with evidence-based practices at all times. So you can always ask the question, where is the evidence base for this textbook? Many times textbooks don't have them. And since we don't have an evidence base right now, let's use something that we know has an evidence base, and that is teaching explicitly. Now, the thing that you can do, Christy, is that you can take that problem that's presented at the beginning of the chapter and you can teach that problem explicitly. There's nothing wrong with that. So it might just be going about attacking that same problem in a slightly different way. And so I would say your best option for explicit instruction, if you want the just like, I'm going to read about explicit instruction tonight, is this book. I really think it's great, and I'm not selling this book, and I've only met Anita Archer, but I should tell her that I've made like 100 people buy this book. I think it's super helpful. There are also some really good practice articles that I could send you about teaching mathematics at middle school using explicit instruction that aren't research heavy, that they're more like, here's how we did this as teachers, and here's how this worked for students. So that would be super helpful. Is there another question? Kelly Robinson, I thought you were going to come through with a question, but instead just a very nice comment. So I thank you for that as well. But are there any other questions about mathematics?
Sarah, we had a couple questions submitted before the
Cool.
webinar.
All right, take it away, David.
And a lot of them kind of did focus on the interventions, and maybe like you would reference those pull-out interventions at tier 2 or tier 3. And so kind of even in the beginning, what is one of the most reliable ways to identify those students in need?
Reliable ways to identify students or identify interventions?
Both. Like to identify the students in need and then to match the appropriate intervention.
Okay, I'll do the interventions piece because it's a little bit easier and it's a shorter answer. There are several resources that are available in the United States to people that have actually like said that this is a research validated practice and you should be using it. One is the What Works Clearinghouse, pretty good for general education resources. The thing is, when you go on there, you're going to just see that a lot of things are not supported by evidence, or maybe that they don't really show significant growth for students. But the What Works Clearinghouse is continually updating itself. And if you just go to whatworks.gov, it'll take you there and you can put in math and middle school, and it'll come up with a list of programs that have been shown like strongly, that have a strong set of evidence, have okay evidence, and have no evidence. And many times you will find that whatever you're using in your school is on the no evidence list, which is always a little disappointing. In terms of students with math difficulty, the Best Evidence Encyclopedia is somewhat helpful. The National Center for Intensive Intervention, which is intensiveintervention.org, they have gone through and found like tier 2 and tier 3 interventions in mathematics that are helpful for students and present the evidence. But on the intensive intervention website, I think maybe only like 1 or 2 of the programs is for students at the middle school level. Like there's just not that much out there, which that's where I think like if there's not a specific program, then you have to have like this more general framework in terms of, okay, how do I teach changing dimensions? There's no evidence-based practice for that. So I'm going to use these tenets of explicit instruction to inform my teaching about changing dimensions. So that's where you can go to. Those are pretty much like the 3 top websites for resources right now. In terms of identifying students, kind of depends on whether the school is doing something that looks like RTI or is RTI. But it is typically screening classrooms for students that look like they're at risk, and then seeing if those students are responding to general education instruction. Almost all the time, this should be done through formal progress monitoring, although we know a lot of schools do it through more informal measures. But formal progress monitoring measures like DIBELS and AIMSweb. DIBELS does have a math series now, which not everyone is aware of, or AIMSweb or EasyCBM. They have benchmark data that go along with it, which are super helpful. So if you give this assessment to your class and you can see like, oh, in 6th grade, if students are scoring below 15, that means they're not meeting this benchmark. Those are probably the students that need the intervention. But I do know with like the Middle School Matters project, I've been in some of your data rooms and you guys have a lot of data on these students. So I would be picking those students that are those students that are the lower performing students. And pretty much I've seen like rankings of these students and saying like, okay, let's take these 6 students, let's figure out what foundational skills they need to work on, and then let's provide intervention for those students. And then let's take the next group of 6 and let's figure out what they need to work on. Because many times all those students are in the quote red, but they may need different things. And so figuring out how to group the students and how to provide that intervention to students. And one of the questions that will come up is like, when do I do that in the school day? And I'm not going to answer that at this today because that is the hardest thing to answer. So I'll let schools figure that out. And I can help them brainstorm, but I don't want to get into like the logistics of it because that's the hardest thing about providing intervention at tier 2 and tier 3. What was another question, David?
You actually kind of already touched on a lot of the others.
Okay.
Because there were some questions about grouping the students that you had mentioned, and you even
Continuous grouping is really shown to be the most effective use of students' time and teachers' time. So grouping students by, hey, these students all need work on blank, so let's work on this.
great. And then also you touched a little bit too, because a question about like monitoring the progress. So I guess if Dibbles has some of those benchmarks, then they probably also have the progress monitoring, so you can assess their progression of mastering those skills.
Exactly right. Yeah. So, and there are, the different types of progress monitoring measures. There's like mastery measurement, where it's like, does this student know their multiplication facts? Then there's what they call general outcome measurement. It's like, does the student understand everything in math that you're expected to do it by the end of 6th grade or 8th grade or whatever? And those general outcome measures are better for progress monitoring because they're kind of like giving you a bigger picture, a bigger scope to understand like what is this student, what do they know in mathematics, and then it can track their progress and like what are they learning in mathematics. And so in some of those general outcome measures you do have to pay for, but others are available for free to download on the internet. But what you're always looking for is normative data that goes along with these progress monitoring measures. So you can download a ton of stuff, but then if you're like, well, what does it mean if a student scores a 6? Many times all the good progress monitoring measures will say the score of 6 means this. That means they're in the green or the yellow or the red or however you want to interpret it. And so that's what you're really looking for is that normative data. And the intensive intervention website, which I mentioned a little bit earlier, intensiveintervention.org, not only do they have a list of interventions that teachers can use, but they also have a list of progress monitoring measures and talking about the technical adequacy. Are the measures reliable? Are they valid? And so you can get a good idea like, hey, should I be using MClass or should I be using Easy CBM? They can kind of help you work through some of those decisions. So
Great. Well, this has been very helpful. One kind of final question and note is
yeah.
any sort of advice for, you've got that small percentage of students right now that they've been struggling, they're in 8th grade and they've been struggling since 3rd grade. They're very behind. They're disheartened, and they're almost hit that point where they're not even really doing much of their work. They're real resistant. Um, any kind of advice for, how to find some success and what to focus on now, because without them giving up being so far behind, but where we can kind of pull out, get some of that content mastery, some of the concepts, I think, like you had said, like,
Yeah.
and
So actually, I think my answer to that, David, is going to go a little bit against conceptual stuff. And I know that like our group in South Carolina is doing this. I've been talking about to the group in Erie about this. Is that students do get very disheartened by mathematics, and I feel, and there are other math people that feel this way, is that if you can improve like the very basics, like fluency of students, then when they're solving these problems and they get to like, oh, well, I don't know what 8 times 7 is, so I'm not gonna do this fractions problem. But when they do know 8 times 7 is 56, then they're like, oh, I can solve this problem. And it starts to add to their confidence and it lessens their anxiety. So I feel like one of the best things that we can do is really try to improve the basic fluency of these students. And we know that these middle school students not only struggle with basic fluency with multiplication and division, but also have struggle with addition and subtraction fluency. So I think maybe even just like taking it back to some of these basics and you embed that fluency practice in when you're talking about slope intercept form. I mean, it's pretty easy to do, just like a little warm up at the beginning of every lesson. But sometimes taking it back to giving students like filling their toolbox with some of these more basic foundational skills is then increases their likelihood of being able to solve these problems later on and feel like they can attack these problems, because we know many times students, they're just like C, D, This is like math seems like magic, and math is not magical. Math is actually like completely practical when we break it down for students in a manageable way. So I would say fluency could really go a long way for students.
Great. Well, thank you so much. And I know we're right at the end here. So thank you all.